Hi, and welcome to the 2018 Paper 2 of the Junior Cert Higher Level. This is question 11 we're on now, and it's only basically a one-part question. It's worth a lot of marks, 15D. Trigonometry, or seems to be. So let's get stuck in. But just if you want this set of notes I'm working off, please read the description below and send me an email at shanetroy@gmail.com. So F is an angle in a right angle triangle. Okay, so without even doing anything, okay, now I'm going to draw a guide diagram. That's a right angle triangle. Okay. And F is one of the angles. Okay, not the right angle. So we'll call it F there. So now it's supposed to be an F. That's the hypotenuse. If that's the angle, that's the opposite. That's the adjacent. Now, cos of an angle is the adjacent over the hypotenuse. Okay. So cos does relates to the adjacent side to the longest side. The adjacent is 6 units long. The hypotenuse is 11 units long. We don't know the angle, okay, although we can find it. So it says, by drawing a diagram of a right angle triangle, find the value of sine f. Give your answer in sword form. Now, what's the answer? Okay. So I've said that their cosine relates the right angle, the adjacent side with the hypotenuse. So I've said that all that there so far. Now we need to find sine f. So we're going to have, basically in the sense of I have a representation of it there. We need to find this opposite side in order to fill in the sine ratio, which is opposite divided by hypotenuse. Okay. Now the only way to find the opposite side there, okay, is either find the angle f, okay, and then find the opposite, okay. The simpler way might be just to use Pythagoras, okay. I've done it here. We know the hypotenuse, okay. We know the one of the other two sides, so we know one of the three unknowns. Okay, I mean two of the three unknowns. There's only one unknown, so I fit in there. Okay, that's Pythagoras' theorem first. Fill in the 11 and the 6. Make sure you have them the right size. The hypotenuse should always be on its own. Then just use algebra to bring I suppose I'm converting the numbers, squaring them first. 11 squared is 121. 6 squared is 36. Bringing them to the numbers to one side. The plus of the right hand side changes to negative on the left hand side. Do that little sum. I get 85. Now 85 is equal to some number squared. Now to find that number, bring the square across. The equal changes to its opposite, which is the square root of 85. And I end up, if I put that through the calculator, I get a decimal, so I might as well leave it in square root form. I now know that the length of the opposite is square root of 85. I know that sine of an angle relates the opposite to the hypotenuse. So it's square root of 85 over the hypotenuse of 11. And that's my answer. It's in sword form because it's in square root form. Job done. Okay, that's question 11, so see you on question 12.